So, greetings of the day. Myself, Dr. Nivedita Dutta, and today my presentation is on representing dental restoration materials in the oral health and disease ontology. So, this is basically an collaborative approach. Here, in this collaboration, there are domain experts and ontology engineers. And obviously, I want to thank especially to William and Alex for providing us as the platform to contribute our expertise. So this is the brief outline why we need to represent dental restoration materials in the oral health and disease ontology. How was it done and what did we achieve? This is a brief introduction of oral health and disease ontology. It is an over-boundary ontology for representing oral health conditions, diagnosis, and treatment. It aims to support the translational medicine and integration across the oral health research and clinical domain. From these publications, the initial development procedure can be seen. So what is actually the dental restoration material? It is the main treatment option for diseases like dental caries, which affect more than half of the global population. It also the treatment option for traumatic dental injury, which also affects a large population, like 15 to 30% of total global population. And also it is used for aesthetic dentistry, like tooth veneering and treatment for oral rehabilitation. So the requirement can be seen from the steady market growth. This is the data. But for ontological representation, this domain is little bit complex because of its interdisciplinary nature. It comprises knowledge from dentistry, from material science, and also from general medicines. So our objective is to develop a structured and reusable ontology module for dental restoration materials within the OSD framework. And this is the methodology. The main outlines are first to define the scope, as because it is an interdisciplinary domain. So we need to mark the boundary among how much to take from different subjects. We use cases for that purpose. From the use cases, we generated the competency questions. We catalog the required terms. The next part was analyzing existing sources for our requirement. So for this reason, we took the help from Ontobi, Ontology Lookup Service, BioPortal, MacPortal. And these are the names of the terminologies and ontologies where we found the mention of the dental material. That part will be discussed later also. So next, the ontology development framework. It is an interdisciplinary collaborative approach from scratch. So it helps us to iterate from the initial level. We reused OVO ontologies, and BFO was our upper level ontology, constructed logical definitions and axioms for the classes. These are the use cases. We gathered few of the use cases actually. Just like one, the rapid introduction of new ceramic dental materials. Due to this, clinicians face increasing complexity in selecting the appropriate material for clinical indications. And sometimes the selection criteria are very vague, like the in vitro testing properties of materials, the manufacturing techniques, sometimes the preferences of the dental laboratory technicians, and unfortunately, sometimes the marketing claims also guide the clinicians to select a material. So from this, we generated that type of competency questions like, how can dental restoration material be classified based on compositional and microstructural variations that influence their performance in different clinical indications? These are the other use cases, like use case 2. Suppose in a less equipped clinic, a child patient comes with multiple caries in deciduous dentition. So dentists need to select a material which said by chemical reaction and which should have anti-cariogenic effect and preferably of low cost by avoiding the lab costs. So from this, the competency question is find a dental restoration material with fluoride ingredient set by acid-base reaction where fluoride is known anti-cariogenic agent from the clinical level. And the third case is a dental material researcher is searching few specific articles on zirconium ceramic dental materials and facing difficulty due to the term ambiguity. So from here we generated this question that what is the compositional specification of zirconium ceramic dental material to distinguish it among other ceramic dental restoration materials. From these through these competency questions, we tried to search the existing sources like the NCIT. Here already restoration material is present with different subclasses like amalgam, porcelain veneer, resin-based composite, and flowable composite. But as I found that amalgam and porcelain veneer both are subclass of restorative material where basically veneer is a device. So this is a type of ambiguity from our perspective. And also resin-based composite, flowable composite, hybrid composite, all are subclasses of restorative material. But in reality, the flowable composite and hybrid composites are basically the subtypes of resin-based composite. So these are the ambiguities we found. This is from Snowhead City. Basically, it is a popular terminology and a broad domain coverage is there. We found different dental material related terms like amalgam, dental cement, zinc oxide, eugenol cement, glass ionomer cement. But as we searched and I found that the classes are not clearly categorized with a compositional detailing, and it is difficult to correlate their properties on the basis of structural variations. Sometimes the representations omit the other important clinical applications like as it is the glass ionomer cement is classified under following parent class like dental cement, fissure sealant material, root canal filling material. But in reality, sometimes clinicians prefer to use it for class 1 cavity, for the cavities of deciduous dentition like that. This is MES, medical subject heading. It is a very vastly used control vocabulary for indexing biomedical literature, and a broad domain coverage is there. However, we found that its description reflects a limited view of the material's actual clinical use, like for dental cement, the substance used to bond composite resin to dental enamel and dentin, and these bonding of or luting agents are used in restorative dentistry, root canal therapy, prosthodontist, and orthodontist. Somehow, there is also, we found the limitations of the actual clinical uses. This is the elementary multi-perspective material ontology, and it is basically a upper level ontology of material science domain where we found composite materials, ceramic materials, metallic materials, and polymeric materials. And those are modeled as a subclass of physical object, and basically it emphasizes on the physical and structural characteristic of material. And in its current form, it does not support the representation of clinical or dental procedures and lacks the construct to distinguish material based on anatomical location or procedural context. This is another one, device experimental scaffold and biomaterial ontology. Here also we found mention of different biomaterial type like alloy, ceramic, composite, glass, metals. But we found the ambiguity like, and few other types of dental materials like cement or adhesives. They are not under a biomaterial type, rather they are under the manufactured object. And we could not get any logical basis for this type of classification. So from all those surveys, we found some requirement to represent dental restoration material. And this is the result of our representation. We first categorized each dental restoration material primarily based on its molecular structure. Mainly material, we follow initially the material science perspective, like we divided all the materials under metal, polymer, and ceramic. But presently, there are a huge number of materials which we could not just categorize under either metal or polymer or ceramic, but they are basically combinations of metal, polymer, or polymer ceramic like that. So we created the distinguished classes for those like composite resins and cements. So this is the classes and subclasses of dental restoration material. The result is a structure-based classification of presently available dental restoration material. We provided distinct definitions in genus differential formats, and the definitions was based on trusted sources with use of annotation property definition source. These are some examples of the detailed descriptions process we followed. This is the different cement dental restoration material, sorry, and this is the different types of ceramic materials. So this is the schematic representation of the restoration material we used. As a parent class, we used the process material, which can carry the information about the processes by using the object property has specified input of the material processing, because basically dental restorations materials are result of different type of material processing like sol gel processing or ball milling like that. So this representation helps to properly represent those detailings. This is the complete semantic representations of the oral in the OHT, the actual position of the dental restorations material and the other classes. Next, we try to evaluate our development through the competency questions we gathered. For example, the first one, how can dental restoration material be classified based on compositional and microstructural variations that influence their performance in different clinical indications? So this is the protege view where you can see that there are distinct classifications of ceramic dental restoration material, metal dental restoration material, resin dental restoration material, and different cement dental restoration material with clear and distinct definitions, with also the mention of the definition source. It is another main class of metal restoration material with their subclasses, and there is a mention of which one is of noble metal dental restoration, which one is base metal dental restorations. So our next competency questions was to find dental restoration material with fluoride ingredient set by acid-base reaction. This is the protege view of the result. Here we can see that under the acid-base cement dental restoration material, there is glass ionomer cement dental restoration material, where the definitions is clear definitions is provided, and from here we can get that it is a iron leachable glass. It contains iron leachable glass, that is fluoroaluminosilicate glass. We also added the axioms where we add that it has ingredient fluoride, so that it helps to get the answer. And this is the another competency questions that what is the compositional specification of zirconium ceramic dental material to distinguish it among other ceramic dental restoration materials. So this is basically the detailed classification of ceramic dental restoration material that there are the different types of this, and one is zirconia polycrystalline ceramic dental restoration material, and basically these classifications helps to uh, either narrowing or broaden the search procedure, whichever is required. So the conclusions are, it is an interdisciplinary collaboration from scratch. And here the dental domain experts are both from clinical environment and from academics. So it helped to capture the ground truth concept of the clinical dentistry with maintaining the science. The trusted definitions with definition source annotations ensure the reliability from peer review literature and standard textbooks. It helps to remove the ambiguity of the terms, and it provides a semantic clarity, ensuring unambiguous understanding of the materials across research and clinical contexts. So our future work is to capture the intrinsic physical, chemical, and mechanical properties. Our idea is to reuse terms from platform material digital core ontology, which is a mid-level ontology designed to support the data representation from material science perspective, like manufacturing, laboratory workflows, and device-specific data, and to utilize the representation for annotating the research literature on dental materials to facilitate the knowledge extraction and interoperability across the related datasets. So finally, I want to express my gratitude to the WHD community and all collaborators. Basically, this effort took some time, obviously, because it is a completely manual approach, but every discussions help to refine the idea and the criticisms that shape the idea into a clear concept. So basically, this journey reaffirms that through shared understanding, it is the best way for a structured knowledge representations. I also want to thank the reviewers of Journal of Biomedical Semantics for their valuable feedbacks, and the Protege open source user-friendly ontology editor platform, Dr. Somen Sen and Dr. Ujjwal Das for their expert suggestions and support. These are the reference, and thank you very much. This is the GitHub side of the WHD. You can access it. So thank you.